guys, today we learned about Descartes' rule of signs. These rules tell us how we can determine the number of possible positive roots, the number of possible negative roots, and the number of possible imaginary roots. Okay? So the number of positive roots, it's equal to the number of sign changes or less by multiples of 2. Okay? The number of sign changes or less by multiples of 2. I think that for the interest of this, we are going to skip this first problem and go straight to example 2. Okay? So in example 2, positive, negative, imaginary. So in example 2, in order for us to determine the number of positive sign changes, we have to count the number of times the signs change. So the first sign of this x to the 6th power is positive. So from a positive to a negative, that's a change. From a negative to a positive, that's a change. From a positive to a negative, that's a change. From a negative to a negative, it stays the same. So there's no sign change there. No sign change and no sign change here, which means there are 3 positive sign changes. But the number of sign changes is equal to the number of positive roots or less by multiples of 2. So from 3, we can subtract 1. So we could have 3 positive roots or we could have 1 positive root. But those are only 2 options for positive roots. In order, let me highlight this so you know that this is the number of positive roots, okay? Now to determine the number of negative roots, what we have to do is we have to replace x with negative x. So that's going to be negative x to the 6th minus 2 times negative x to the 5th plus 3 times negative x to the 4th minus 10 times negative x cubed minus 6 times negative x squared minus 8 times negative x minus 8. So when we simplify this, we have a variable, negative number, raised to an even power. It's going to be positive. So negative x to the 6th is actually going to be positive x to the 6th. And x to the negative 5th, negative x to the 5th, since 5 is odd, this is going to be negative x to the 5th. When we multiply it times this negative 2, it's going to end up being positive 2x to the 5th. Now this negative x to the 4th, since we are raising a negative to an even power, it's going to be positive. So that's positive 3x to the 4th. Now this negative x cubed is going to end up being negative since it has an odd power. When we multiply that times a negative 10, we're going to end up getting a positive 10x cubed. And this negative x squared is going to end up being positive, but we have the negative 6 out front, so that's a negative 6x squared. Negative 8 times negative x is positive 8x, and then we have negative 8. At this point, we want to look at our sign changes. So we're going to start off here, positive x to the 6th to positive, so that's going to end up not being a sign change. Positive to positive, nothing changes. Positive to positive, nothing changes. Positive to positive, nothing changes. Positive to negative, that is a sign change. Negative to positive, that is a sign change. And from positive to negative, that is a sign change. So there are also going to be 3 negative roots. But as we can see from our table above, it says that the number of sign changes or less by multiples of 2. So 3 is the number of sign changes or less by multiples of 2, which means we subtract 2. So 3 minus 2 is 1. Okay? If you see the number of negative roots, the first thing we have to do is plug in negative x for x, which we did do here. Once we plug in negative x for x, we want to evaluate this and find the number of sign changes, which we found to be 3. So you can see here, 1, 2, 3. Okay? or 2 less than that, which is 1. Now, we know that the sum of our roots has to be equal to our degree. So we're adding 3 and 3. We want to get 6, which means that there are going to be 0 imaginary solutions. If we have 1 positive root and 1 negative root, but need a total of 6 solutions, that means we're going to have 4 imaginary. There are still more options, though, because we could have 3 positive solutions. We could have 1 negative root, which is also a solution, and that would mean in order for us to get 6, we're going to have 2 imaginary solutions. Or we could have 1 positive, we could have 3 negative, and 2 imaginary, because that is also equal to 6. The imaginary, as you can see in our table, they're always in pairs. They have to be in pairs. So, they have to be even numbers, 2, 4, or 0. 2, 4, 6, 8, 10, or 0. These are the only options for our imaginary solutions. If you think about when we solve a quadratic equation and we have, for example, when we solve a quadratic equation and we have 2 solutions, it's plus or minus I, or plus or minus the square root of 3i. Think of it that way. That's why we have to have 2. We're never just going to have plus I. It's always going to be plus or minus, because since we're taking the square root, we're going to have 2 solutions there, and that's why the imaginary numbers, or our imaginary solutions, always have to be in pairs. And let me just color code this so you can see that imaginary, that's this one, negative corresponds with the second column, and positive with the first, okay? Now let's go on and do the same exact thing for number 3. Okay, so we're going to make our chart positive, negative, imaginary. The number of sign changes, no sign change, yes, a sign change, C for change, and no sign change, so 1 positive. Now remember, in order for us to determine the number of possible negative roots, what we're going to do is we're going to plug in negative x, 4x, so that's negative x cubed, plus 3 times negative x squared, minus 6 times negative x, minus 8. That's going to end up giving us negative x cubed, plus 3x squared, plus 6x, minus 8. From negative to positive, that is a sign change. Positive to positive, no change. And positive to negative, that is a change. So there are going to be 2 negative roots, which is going to leave us with a total of 0 imaginary, because 1 plus 2 plus 0 is equal to 3. But since we have 2 imaginary or 2 negative roots, we can also have 2 less than that. So we could have 0 negative roots. That's a possibility, which means we have 1 positive and 2 imaginary. Again, this is still equal to 3, so it is a valid option. And those are going to be our only 2 options. We cannot subtract 2 from 1 because it would give us a negative number. So if you get 1, if you only have 1 sign change, then you're not going to have any other options other than 1 in that column. Okay, let's look at number 4. So on number 4, we're going to make a table. There's a, from positive to negative, that is a sign change. There's no change from negative to negative. And from negative to positive, that's a sign change, but no sign change from positive to positive, which means we have 2 positive sign changes, which also means that we can have 2 positive roots, or 2 minus 2 positive roots, which would be 0. When we plug in negative x, that's 2 times negative x to the 4th, minus 3 times negative x cubed, minus 4 times negative x squared, plus negative x plus 5. So that's 2x to the 4th, and that's a negative x cubed, which is going to be negative, but we're multiplying it times negative 3, so it's going to be a positive 3x cubed, Negative x squared is positive, but when we multiply that by negative 4, we get negative 4x squared. This is just negative x plus 5. So now we just have to count the sign changes. From positive to positive, no sign change, but from positive to negative, that is a sign change. Negative to negative, no sign change, but from negative to positive, that is a sign change. So the number of possible negative roots are going to be either 2 or 0 as well. If we have 2 positive roots and 2 negative roots, then we're going to have 0 imaginary because we need the sum to be 4. If we have 0 positive and 0 negative, then we have 4 imaginary because we need the sum to be 4. We could also have 2 positive and 0 negative. So that's 2 plus 0, which means we're going to have 2 imaginary in order to get the sum of 4 total solutions. And there's one other option, which would be 0 positive, 2 negative, 2 imaginary, which would give us a sum of 4 solutions. Okay? So the rest, the back of this is for homework, those 8 problems. Please remember that I have tutoring every day after school, and you can watch this video and other videos as well.